All right, it is 12:01. Let's go ahead and get started. Thank you for joining today. Today's webinar, we're going to be discussing point displacement measurement and subsurface monitoring of slopes. And just so we're all on the same page here, by point displacement measurements, we mean things like prisms, GNSS, extensometers, so on. The famous zippometer, which maybe Zip will talk about later, which we don't recommend. And also subsurface monitoring tools like TDR cables and shape arrays and so on. So we've got our panel of experts here today to answer your questions. Before I introduce them, let me give a little bit of background on the Geotechnical Center of Excellence. So the GCE, we are at the University of Arizona. We're part of the School of Mining and Mineral Resources. We are an industry-funded and member-led group. We conduct collaborative geotechnical research and education, and we are a very interdisciplinary center. We bring in a lot of different folks from geoscience, engineering, computer science, and so on. And we really pride ourselves on bridging gaps within and between academia, industry, and other fields of study. So as I mentioned, we are member-funded and member-led. So here is a list of our member companies. Without them, none of this would be possible. So we want to give a huge shout out to them for their ongoing support. Really great group. If you would like to join our membership, we'd love to start that conversation with you. So you can reach out to us. Probably the easiest way is send us an email, gce@arizona.edu. Maybe I'll ask one of my colleagues to go ahead and put that in the chat just so you can have that at your fingertips. So today's webinar is based on two of our professional development courses, which are currently running. The first one is slope performance monitoring. All of our courses are online. They consist of pre-recorded videos by industry experts. And the slope performance monitoring course is based on the Large Open Pit Project Guidelines for Slope Performance Monitoring book. We have one of the editors of the book here, Bob Sharon. And the LOP also underwrote this course, so a huge shout out to them for helping develop the course. The other course that is currently running is the Geotechnical Radar Monitoring course. This course is solely focused on ground-based and satellite-based radar for monitoring slopes. If you'd like to learn more, you can scan the QR codes. I'll ask my colleagues again to put those in the chat so you can have them. Okay, a couple introductions. The GCE webinar team, I will be moderating today's discussion. My name is James McNabb. I'm a Senior Research and Development Engineer here at the GCE. I'm joined by our Professional Development Program Lead, Cheryl Bukowski. Thank you for joining, Cheryl.
Hi, everyone. Thank you for being here.
As well as Benjamin Meyer. He is our Software Engineer, Research and Development. Hello, Benjamin.
Thank you. Hello, everyone. Thank you for joining us today.
All right. We'll introduce our expert panel, starting with Bob Sharon. He is the Director of Geotechnical and the owner-operator of Sharon Geotechnical, LLC. He's also a technical advisor for the Slope Performance Monitoring course. Hello, Bob.
Hi, James. Thank you very much for inviting us for this program, and looking forward to talking to all of you about it. And hello from Tucson.
All right. Next, we've got Paolo Farina. He's the Managing Director of GeoApp. He's also a technical advisor for the Radar Monitoring course. Hello, Paolo.
Hello. Hi, everyone. And thanks for the opportunity to be here with you. I hope it will be an interesting session.
Absolutely. And thank you for joining from site. We really appreciate that. Next, we have Zip Zavodny. He's a Senior Geotechnical Engineer with Zip Zavodny, LLC. And he's also a senior advisor to the GCE. Hello, Zip.
Hello, everybody. Looking forward to the discussion today from Salt Lake City.
Where he could be skiing, but he's joining us today,
That's right.
So we appreciate it. All right. Next, we have Nani Mapatua. He's a principal surveyor with Debswana. He's also a presenter in the Slope Performance Monitoring course. Thank you so much for joining, Nani.
Hello, everybody. I'm very happy to be joining the discussions. Looking forward to the value-adding discussions that we are going to have today. Thank you so very much.
Great. Thank you, Nani. Okay, we have Pierre Choquet as well. He is a technical advisor with Orica, and he's also a presenter in the slope performance monitoring course. Hello, Pierre.
Hello, everyone. I don't think I have my video available, but hello, everyone. Glad to be here, joining from Vancouver.
Great, thank you. Okay, before we get started, just a little bit of housekeeping. If you are tuning in today, you are muted and your video is off by default. If you'd like to ask a question, which we highly encourage, that's kind of the purpose of this webinar, we encourage you to use the Q&A function at the bottom of your Zoom control panel. There's a chat function as well. We encourage you to use that for anything, saying hello, where you're from, if you'd like to just make general comments. But if you have a specific question, please use the Q&A function. That helps us kind of keep track of everything. The questions can also be anonymous in the Q&A function if you so choose. Also, this is a recorded webinar, and we'll post this to the course sites as well as our YouTube page. And just a quick disclaimer. Please note that the views and opinions expressed by our panelists are their own. They do not necessarily reflect those of the GCE or any affiliated organizations. All the webinar content is intended for educational purposes only. It is not intended to be a substitute for site-specific professional advice or analysis. So thank you for bearing with me on that. And so let's start with a quick kickoff question, just to get things rolling. Okay. Many large open pit mines now use a combination of point displacement and subsurface monitoring systems in addition to ground-based radar, INSAR, and drones to monitor slopes. Are these diverse large data streams being integrated effectively, and where do opportunities still exist to improve our understanding and predictive capabilities of slope deformation using this wealth of information? And I realize that's kind of a long statement there, so maybe we can take a moment to wrap our heads around it. But maybe I will, just to get the ball rolling, ask Bob if you could get us started.
Yeah, sure, James. Yeah, we kind of preoccupy ourselves as people who provide services to a number of mining operations around the world about how best to use monitoring information. And just a couple of comments on this one is that we do have excellent instruments, sensors to monitor slope stability in particular. The technology is very good, and the services are also excellent for being able to present data and to help us practitioners to interpret the results of monitoring. And I've been to many operations who do this very well. They'll take like point measurements, for example, combine it with other data for interpretive context. So if you're monitoring slopes with prisms, for instance, a lot of operations nowadays are increasing utilization of ground-based radar systems, INSAR, and then other types of instruments to monitor pore pressure, like vibrating wire piezometers and so forth. So there's a lot of information out there that can be joined if it's done effectively to interpret movement, not just the movement itself, but also to interpret why ground is moving. And one good example could be if you're getting a lot of rain. So the slopes are taken in rain, you're getting a response to pore pressure increases that could induce slope movement. So if we could bring these types of information together to look at it at the same time, that helps us with interpretive context. And a lot of operations I've been to do this very well. They have systems integrators to help them set up their monitoring systems so that they can look at this data in real time. They'll create time series graphs of different types of movement so that over a same period of time, so you can examine the data together. So not only are the systems good, in my opinion, but a lot of operations do use it effectively. Now, there are a lot of other operations out there who have these capabilities but don't do it so well. So we see, at least in my experience, is a lot of operations who do this sort of thing well, and others that don't do it so well. And it's not that they don't have the capability to do it. It's just that the instructions are not getting out there to support personnel like your systems integrators to help set this data up. One criticism that I have of a number of operations I still do work with is that they don't use the total station prism monitoring systems effectively. Most, I'd say half of the operations that I do business with nowadays actually look at vector data like northing, easting elevation and total vector along with slope distance or line of sight measurements. So it's easy for these operations to just use line of sight, and they feel like that it's effective enough for prisms to look at it that way because they also have radar, ground-based radar systems or NSAR to look at, but it's still not enough. And so people like me are still out there trying to push the idea that, look, you have the capabilities of getting total survey monitoring information from your prisms. And we encourage people to use it because it helps not only to understand where all of the movement is coming from and not just the line of sight, because you may miss it otherwise, but it also helps the slope engineers to interpret a slope failure mechanism, which line of sight arguably does not allow you to be able to do. So we think that there's a lot of room for improvement at a lot of operations to use prism monitoring data more effectively, and then also to bring in other sources of data. And if it's automated, you can have access to this data in real time. So it helps you to make more informed decisions about what your slope monitoring information is telling you and how to react to it. It'll also help with risk management, sharpen your tarps and so forth. Anyway, that's a long answer to a pretty basic but very good question here. So thank you for bringing it up.
Great. Excellent kickoff. Any other thoughts on this one?
Yeah, just a couple of comments, how important it is to link subsurface with surface data. A lot of operations think that it's sufficient to have just the surface data, but some of the more complex failure modes really benefit from subsurface data. And I found over the years that a good extensometer, subsurface unit, inclinometer, shape array, etc., sometimes provides critical information before it's even documented on the surface. So subsurface monitoring is a very important key ingredient input into our Scientology. One thing, just to expand a little bit on what Bob said, a lot of operations properly use the data and look at it on a regular basis. But I have also seen in a couple of cases where there's a shortage of manpower, etc., they'll have a sophisticated piece of equipment looking at their slopes, but are not watching it on a regular basis. And that can be a real problematic issue, especially should you have a failure that results in some impact to the operation from a legal standpoint. I think the moment you have one of these sophisticated systems, you need to watch it carefully and act upon it on a regular basis.
If I can add on top of what Zip said, some personal comments. I fully agree with the need to take a look at subsurface monitoring data because this is mandatory, in my opinion, to understand the mechanism and sometimes to anticipate the occurrence of instability at the surface. And in general, my experience is that most of the mine sites now are using a sophisticated monitoring system, including surface and subsurface sensor. but most of the focus is on safety critical monitoring, which is, of course, the priority, and it's clear. But when it comes to make what I call investigative monitoring, to understand if there is the potential for a large-scale instabilities, so making a more strategic monitoring, sometimes my experience is that there are still limited practices to support the analysis of data with the aim of understanding the potential impact of a slow moving area, a large scale that could develop in the forthcoming months following, for example, mining. So that's something where, in my opinion, there is a lot to do still, because we have data, but the most important point is how we analyze those data in a routinely way, and how the staff on site is looking at the data. To have good technology does not mean that we have a safe operation or an efficient operation, because we need to have people that spend time looking at the data and understand those data. It's clear that nowadays we have a huge amount of data collected by the different technologies. So it's important that the supplier develop tools, algorithms, also taking advantage of machine learning, why not, to support the user in filtrating data and extracting, squeezing the most important information content of those data. This is something that, in my opinion, is still at the beginning. There is a lot to do. And but in order to do this, we need also trained user that understand what is the scope of each technology and how to use the data with the right workflow. That's my comment.
Thank you.
Fantastic.
Thank you very much.
If I can add the point of view of the supplier here. This is Pierre Chacot speaking. James, you introduced me as being with Orica. Actually, I'm with Orica Digital Solutions.
My apologies. Thank you.
That's okay. And it's a rather recent entity that, or at least the Geo Solution part of Orica Digital Solution is a rather recent entity because of a recent acquisition of Orica. So now there is 6 geotechnical monitoring companies that are together: RST, Measurant, Review Geomatics, Ground Probe, etc. And what your triggering question is viewed, I believe, in the industry and also from the supplier side as a little bit the holy grail, in the sense that how can we visualize, integrate, interpret, analyze, and so on in ground and the surface and the remote sensing data in order to have a global interpretation of what's happening for the pit slope, in the ground, for tailings dams, and so on. But I think that a lot of people are working hard in that direction, and there are actually a lot of installed situations where that integration is already not so bad in terms of software, in terms of hardware. But yes, it's something that is needed by the industry. The suppliers have got the message and they're working hard on it. There are some quite good situations, examples to showcase. And as has been said a couple of times by the previous people here, it's all related also into what's the availability of the mine engineers, the personnel, the EORs, and so on, to review the data and to actually do that analysis. It won't be done by itself just because you have the software. That analysis needs to be done as well. So it's a known situation. Thank you.
Yeah, thanks, Pierre. Nani, I saw you had unmuted earlier. Would you like to add?
Yeah, thank you. We, as a practitioner, I've used most of the systems that have been listed here. The approach that we have taken at our operations is that we have realized that the different systems have got different capabilities. Hence, we know their strengths and weaknesses. So what we do is we identify the type of movement that we are monitoring, and then we select the appropriate equipment as the primary monitoring system for that particular area. However, we still complement the system with other systems. So what we then do is using an integrated system, we then do a cross-functional analysis, like we will compare the movement that we are picking using prism monitoring, and then compare it to the radar system. So we found out that in terms of comparing a cross-functional analysis, the level of confidence in the data from our analysis improves because we have to check movement using a different systems. So we really appreciate that. We are mining. We're in a process where we have mines which are becoming dormant in care and maintenance mode. So what we are trying to do is phase out the rapid monitoring systems like Prism and ground-based radar and see, because the risk is low, whether we can compare it. We can use drones to monitor those systems. So what we do, we are gradually comparing the movements that we are picking from the drones compared to other primary monitoring systems like radar and prisms. So we are eventually, as we gain confidence in our drone monitoring systems, we're eventually phasing out the others, particularly for the mines that are under care and maintenance. Thank you very much.
Yeah, fantastic. All right, thank you all. Those are great, diverse perspectives. If I were to summarize one of the main themes, it might be it's one thing to invest in the hardware, but it really doesn't mean anything if you don't invest in the education and the infrastructure, like the software and so on, to interpret that. So great points. There's one question here that was sort of answered, but it's a really good one. I want to bring it up, and it relates to subsurface monitoring. So again, we touched on this a little bit. Presumably, downhole monitoring tools are installed with the understanding that they may soon be destroyed. How do you convince upper management that they are worthwhile? What is the added value of downhole monitoring over surface instrumentation? So I think we established that it is important, but maybe we could talk about why specifically it's important and maybe how you communicate that to the people who are actually purchasing these things.
I can try to give a first comment. It's of course an extra amount of money to be spent in the monitoring system. But if you see, for example, a large moving area from INSA or from radar, first of all, you don't know this technology line of sight, so you miss the direction of movement. But even if you have some good prism there, you can identify the orientation of the vectors. But then, in order to understand what is the volume of this moving area, and that's the first question you have to address in order to assess the risk, you need to install a subsurface monitoring system. Could be a TDR, could be a manual inclinometer, could be a shape array, whatever. But this will confirm, will tell you what is the depth of and then what is the mechanism. This, of course, is something that you need to understand in order, first of all, to understand what is the potential impact of this moving area on operation, because the volume does allow you to estimate the runout. And second point, what is the mechanism? So how this moving area can be, the movement can be mitigated, for example, using the watering, buttressing, whatever. But if you don't have this information, of course, it's hard to take any reasonable decision. So it is some extra money to be spent. Of course, some of these sensors could be destroyed, not necessary, because there are, for example, system like inclinometer, column of inclinometer that can be removed. Okay, you can install for a period and you can remove even if the shearing is pretty narrow and strong. So I think it is necessary to clarify that surface monitoring could be not enough. Another example, and then I stop talking, is when you look, for example, instabilities on stockpiles, on waste dumps, whatever. Those those type of assets are typically moving. They are supposed to move because they may have subsidence, no settlements. So to have movement at the surface could be not enough to say that we are having, let's say, a critical situation potentially developing. So you need to verify what is the, first of all, the mechanism, the depth, and what is the triggering factor. So why it's important to install also piezometer, no? Which is one of the most important sensor in order to understand if pore pressure is playing a role or not on instability.
Yeah, fantastic. Thank you, Paolo.
Kind of to follow up a little bit more about what I said earlier, for very slow moving, large scale displacement, one can get advanced warning from the subsurface that is not necessarily reflected on surface. I've seen this in a number of cases. So it's extremely valuable to have forewarning of an event from the subsurface data. And our systems now are sophisticated enough to give us this advanced warning of very small dilations, but they are subsurface. So a good shape array system and clinometer system is extremely worthwhile, and I think can easily be justified to your senior management as a worthwhile installment and investment.
Yeah, I'd like to add to Paolo and Zip's comments. I agree with all of them completely. All I can really say at this point is to reinforce some very good advice from these guys. Yeah, just taking some personal interest in this question is that usually people who will ask a question like this is, how do you sell or how do you convince management that they need to have some downhole monitoring instrumentation? And there are a lot of operations that where people are really reluctant to spend the kind of money that it needs to put in these types of instruments and then to manage and use them properly. Some of these instrumentations are needed on a very short time basis, and so that's even more difficult to sell. People who ask questions like this are probably have had this happen to them, is that they think that they have a very good justification for doing it, but they just can't, they're just struggling to be able to sell it to management. And this is a matter that for many engineers in particular, they're very good at their business, but maybe not so good as salesmen. So what can you do to try to sell the need for this type of instrumentation? And to do that, you need to be well prepared, to fight the good fight. And that is to take a look at what are the consequences if you don't put in this type of instrumentation. So to answer that question, it requires you to really have a good understanding of the value of putting in subsurface instrumentation. And I agree completely with the comments that Zip just made, is that we can often detect things in point instrumentation that's underground well before you actually see it from the surface. And one compelling argument is from people who have put in seismic monitoring systems or microseismic instrumentation, even into open pit operations, is that that instrumentation has actually been used to predict a failure condition in the future before it was even observed by monitoring on the ground surface. And we have some case studies or case histories about where microseismic monitoring has actually been used for that purpose. So it helps to sell putting in a monitoring system like that, especially under conditions where if you did have a slope failure and that you're not well prepared for it, it could lead to fatal accidents and or pretty serious losses in achieving production targets. So what I'm trying to really say here is that is do some homework as people who are trying to justify putting in underground instrumentation. Is that why do you really want it? What are the consequences if you don't put it in? And have you thoroughly assessed the risk of the balance or the decision whether to put something in or put in some underground mining instrumentation versus not doing it? Just some comments there.
Yeah, very good. I'm sold. Any other comments? Okay.
I'd just like to reinforce Bob's microseismic system comment that I have had very difficult times trying to sell microseismics at a number of operations. However, it is an extremely valuable system to give you forewarning of unstable areas well before they are visually capable of being documented on surface. And likewise, it doesn't mandate the specific area ahead of time, knowledge on a failure mode, because the microseismic system will pick up shearing where nobody has even thought possible could have happened. So it is an extremely valuable tool for a large-scale operation, large-scale, long-term operation. In my mind, a microseismic system is extremely valuable. And we've had some very good luck at Palabora, for instance, in documenting a failure prior to its development on surface, large-scale failure from the microseismic system.
That's fascinating. It's almost like a subsurface INSAR,
Exactly.
monitoring things that you don't know you should be monitoring. Very neat. Okay. Well, thank you all for that very thorough answer. Really appreciate it. I almost skipped it because we covered it already, but glad I didn't. Okay. Let's move on to this next one. So this one sort of piggybacks off of what Nani was talking about with comparing different systems. So what do you do when there are discrepancies between monitoring systems? For example, movement detected by radar that's not observed by prisms in the same area. Is there a hierarchy of trustworthiness? And Nani, since you brought that up, maybe I'll direct this question to you first. And if you're talking, you're muted right now.
I think Nani is not here.
Okay. Apologies, Nani. Well, if anybody else would like to jump in,
I can start.
please. Thank you.
Yeah, that's a good point, because nowadays we have a redundant monitoring system. No? Typically, you have multiple systems looking at the same area. And it's important to, let's say, cross-correlate data from different technologies. Sometimes we have to be aware of the differences that you may have using different technology. Just an example. When you use radar is a great technology, but if you use real-time radar data, you cannot expect to be able to detect the slow movements, the same slow movements that you can pick up, for example, with Prism, okay, or with GPS. So at that point, it's important that if you don't see any movement on the live project of a radar, and you start to see some movements, for example, on INSAR or on the GPS or Prism, it could be simply that the live radar project is not capable of measuring this movement. But if you run a subsampling or slow movements analysis of the radar data, you could probably extend the capabilities of the radar to measure the slow velocities. And so this would then allow you to pick up the movements, or at least a portion of that movement also on radar. And then it's always important to be sure about comparing apples with apples, because we remember that sometimes we have line of sight data, like could be INSAR and radar, and we try to compare with GPS and Prism that are 3D. So that's an important element. So sometimes you don't see that much on radar that you see on the Prism, simply because the line of sight is not favorably oriented with respect to the direction of movement. So these are considerations that we have to do when it comes to compare data from different sensors. But again, it's important to to be sure of what we are looking for. So what kind of movements, and then compare only the technology that can be compared. Okay, so that's my personal experience. From my point of view, there is no a hierarchy in what is trustable. I had bad experience with and positive experience with all the technologies. Prism sometimes not showing anything or showing a movement, a wrong movement, because the reference network was not well placed, no, or the total station was moving. The same applies to radar. Okay, radar with strong problems of atmosphere or with the atmospheric correction too strong done by the radar, because the algorithm does not fit with the spatial pattern of the formation, or because the stable areas are not really stable. So I think we have always to put together the different technologies on the table and then not trust too much any of them, but be critical, trying to understand what I'm supposed to see, no, and then try to see what you see on the different data. So that's my suggestion, my recommendation.
Thank you. Thank you
I'd
so
like
very
to add. Go ahead, Nani.
Thank you so very much, and thank you, Bob. What I was saying is that it's critical, it's very important to understand the capabilities of your monitoring systems. So when you deploy your monitoring systems, you have to understand what is it capable of sensing and what is it not capable of sensing. So as you compare the systems, you should know what is your primary system of monitoring what kind of movement. So as you do the analysis, you should always have in mind the strengths and the weaknesses of your monitoring systems. It happens a lot that you will get one system picking a movement, the other one not picking a movement. But it's a situational analysis to say what type of movement am I picking and what kind of system is optimal to monitor this kind of movement. Thank you so very much.
Yeah, I'd like to add to all of these comments. I think Nani makes a good point by having a good understanding of the capabilities and limitations of these different types of instrumentation, and I think that there are opportunities for improvement with people who are using these types of instruments. Is that there tends to be an over-reliance in a particular type of instrumentation because the operator finds it easy to work with. They're quite reliable. Maybe there is a hierarchy of trustworthiness with the types of instruments that are out there. And I think that these are traps that we as practitioners need to avoid. So having an understanding of capabilities and limitations is really important. And also to have the right types of instrumentation in place for the right types of jobs. What are your risks? Why do you have instruments out there? Have you really do you really have an understanding of the need for instruments, or are you just putting them out there because somebody feels more comfortable? That you have lots of prisms and vibrating wire piezometers and radar systems around the pit to monitor something. Despite how much instrumentation you have out there, I think Zip made the comment before, or maybe it was Paolo, is that you could have the greatest monitoring system available out there, but if it isn't doing the right job for you, you can still have a fatal accident. So that's really important. Understand capabilities and limitations. I think that we should not necessarily establish a hierarchy of trustworthiness in different types of instruments, unless there's a local reason why we don't feel like some type of instrument is reliable. Maybe we have a service problem with say a total station slope monitoring system in place. So if those are issues, then we need to get the service problems worked out. If the instruments are wrong for the job, we need to get rid of those and get the right types of instruments in there. So the bottom line for us is that, in my opinion, there should not be a hierarchy of trustworthiness. Rather, what we should do is have the instruments out there available to help us and fully interrogate when some kind of an exception happens, like if we start seeing accelerated slope movement. What kinds of instruments do we have in place to confirm that that slope movement is indeed increasing? If you have radar and prisms on a slope and both of them are telling you the same thing, then you have data validation. So that helps you to be able to sell a system that will give you both types of instrumentation. They monitor similar things, but of course, because of the capabilities of limitations of prisms versus of ground-based radar, it helps us to validate that something real is happening. And when you bring in other types of data that help you to understand why we're seeing accelerated slope movement, it helps us to interpret why something is happening, what is the cause, what's the trigger, and it helps us to make a decision on what to do with the information. And then a final point is that there's a lot of electronic noise with instruments that are used nowadays. So if you have weather changing on you, pressure is changing, temperature, relative humidity, that can impact our data. So how do we sort out the apparent error caused by atmospheric effects over what's really happening? So what kind of an instrumentation system can we put out there to try to filter out the noise and to really understand what's going on out there? So maybe this is where the subsurface instrumentation helps. Maybe having extensometers on the surface. And then when you really want to make sure that something's happening out there, we have visual inspections, which is probably one of the most, maybe the most important thing that we can do out there, is to visually observe when something unusual is happening. So the use of drones is really helping us in this area to closely look at areas that are otherwise unsafe for us to be able to do the visual inspections that we've done in the past. Thank you.
Bob, I'm glad you mentioned the human monitoring system. Fairly important.
You're going to go into the Zippometer now?
We're getting close to the Zippometer.
All right. Great answers, everybody. Thank you so much. Great question there. Okay. Here's a question. This one is getting a little bit more into the hardware. So maybe I will direct this one towards Pierre. So this one is from Swalran. This is a pre-submitted question. What is the difference between extensometers used in drift in situ tests, such as plate jacking tests and direct shear tests, as compared to those used in mining? And what is the preferred type of extensometer, contact or non-contact extensometers? And which type provides consistent and reliable data? Kind of a two-part question.
Okay. I think we have to remember that the word extensometer is a rather generic word. It can refer to a borehole extensometer. I'll come back to that. And then it can also refer to, well, of course, surface crack meters as well. And indirectly, it can also refer to displacement transducers. And I think that this is a little bit what the question relates to. The type of extensometers that are used for plate jacking tests, and what was the second application? I'm reading it right now. And direct shear tests. Yeah, they're more displacement transducers that are mounted on the testing device, and that measure a displacement that's taking place in the testing device. In the direct shear test, it's just measuring how much shear movement, how many millimeters of shear movement is happening at the same time that you're applying a shear force. And from there, you get the full the displacement curve in relation to shear force. More or less similar to a plate jacking test, which is more for evaluation of Young's modulus of the deformability in rock masses. So the ones that are in the ground, the borehole extensometers, they do have a displacement transducer inside, but then there is quite a lot of hardware around it. Anchors, for example, the borehole anchors to put the extensometer in contact with the enclosing ground, the extension bays or extension rods between two anchors so that you know that you're measuring the displacement between a certain depth and another depth down in the borehole, and then also between a certain depth and the surface. So they have different functions, and one is somehow a component of the other one. I hope that helps to answer the question.
Very much so. Thank you, Pierre. And maybe we can tackle the second question here. What is preferred, contact or non-contact extensometers? I believe this person is referring to line of sight extensometers, laser extensometers, I believe. Could be wrong about that. If we don't know, then that's fine.
Yeah, that might be referring to laser extensometers and by extension to total stations as well.
Yeah.
Mm-hmm. So of course, well, these are mostly for surface applications. That's already above ground applications. That's the difference. And also they allow to measure displacement changes over longer distances. So the laser extensometer or a total station, you have a target which is maybe 100 meters away, 200 meters away, whereas an extensometer is especially, well, with all the mechanical hardware, yes, it can be 100-meter long, 200-meter long, but it's as you're pointing out rightly, it's compact in the sense that the anchor down the borehole is physically connected to the surface or to another anchor. The idea of having non-contact measurements in boreholes, that's not so obvious. Conceptually, maybe, yeah, that it could be a borehole if it's straight enough where there would be a target at the bottom and a laser at the surface, and you would be measuring the change of distance between the two. Yeah, that could work. Well, your laser would have to be aligned very well so that it would really be in the axis of the borehole. And also the laser, how do you call it? The laser light size itself, the red or the red. I'm looking for a proper English word. Let's say Anyway, the laser light size that you would have at the borehole would probably be larger than the diameter of the borehole. So that would have an influence on the accuracy of the measurement. So bottom line, I don't think there are non-contact laser type borehole extensometer yet on the market.
All right. Yeah, thank you, Pierre. All right. I think we'll get away from the hardware question for now, and I think we're going to close it out probably with this last question. We have about 10 minutes. This next question is more of a broad question. I think it will have a lot of discussion here. How do you optimize the handling of large volumes of real-time data without compromising the speed of critical decision-making in mining operations? Pretty big question. Anybody want to get us started on this?
Yeah, I can try.
Thank you, Paolo.
Yeah, nowadays we have a very multiple sensors that collect data with very large amount of data. Now, if you consider radar, this is just an example, no? But even other technologies are providing very heavy data. But we are supported by the technology, because nowadays we have available, let's say, cloud-based storage system that can be used, and we have typically very good internet connection everywhere, even at mine site nowadays. So this can help to, let's say, handling these large volumes of data from one hand. Then the point is how we process those data in order to extract most of the information. Okay, this is another story. And the example I did about the radar and the live processing of radar data versus the subsampling is a clear example. No? In that case, for years, I think more than 10, 15 years, the radar manufacturer focused only on the short-term processing the data continuously. No? So data every 2 minutes processed over a time interval of 1 hour. And of course, being able only to measure very fast movements. And then later on, we realized that the same data, by processing the same data over a longer time interval with less data, selecting only the good one, you can, of course, enlarge the range of measurable velocity by radar, by the radar. So that's an example, but the same applies to INSAR, okay? We are getting INSAR data now every 11 days, every 7 or 4 days at some site. So we are creating a huge amount of data. But the key to me is the way we process data. So the most important step we have to do now is to improve the capabilities with new algorithms, even based on machine learning, to process data in the right way to get what we need. Okay, so from a user perspective, we have to help the industry to make clear what type of information we have to extract from the data, because the industry is able to provide good data. Okay, now it's important to help the industry to define together what kind of information we need to extract from those data. And that's, in my opinion, the key for the next 5-10 years in order to take really advantage of all the data, the large volume of data provided by the different technologies. I don't know if I addressed the question, but I tried.
No, that's great. Thank you, Paolo.
Hey, Paolo, I think you addressed that question really well. I mean, this is a really good question, and the answers are not clear. Just a couple comments to add to yours is, even when even in the old days, when Zip and I were the only guys in this panel actually out there doing this type of work, even in those old days when we had less data, we still had to do some data filtering, and I don't think that the volume of information has obviously increased dramatically, and we have so much more to work with than we had back in those good old days. But we still had to filter data. We still had to kind of make sense out of what limited data that we were getting. We still had the data noise that we had to sort out. And so these things are usually, you address these types of questions or concerns at a mine site on a site-specific basis. Is that, for instance, atmospheric conditions at each mining operation are unique. We have altitude differences, humidity differences, and so forth from site to site. And so we found that just through our experience that we were able to filter data in such a way to get the most value out of it and to make what we believe to be reliable decisions based on that data. So it is a site-specific thing. I think that the slope engineers, the people who are managing and using monitoring information, need to figure this out by looking at how what happens with data that's unique to their sites and what their unique needs are. So what do they call it? Data subsampling that we do so commonly now with ground-based radar systems. People have come up with all kinds of different ways to filter this data to get the most value out of it in as quickly as possible. And then using data integration that we talked about earlier The how do you say it, challenges for us have not changed in our experience. I've been doing this close to 50 years now, and Zip has about 10 years on me with that. And so the problems are similar. I think that one of the things that can really help us out in managing data and filtering data and making decisions from it will come from AI and machine learning. This is still a new area for us, and we're learning from it. But again, whatever we do, whether it's AI or ML or whatever we're going to use to help us sort this data, and data subsampling and so forth is going to be experience driven. And these are all tools. There's no magic bullet that's going to solve these problems for us. And there's still going to be the human element. Most importantly, there will be a human element in making decisions from the data that we receive, analyze, and interpret and make decisions, that could affect people's lives and the in production type things. Thank you.
Yeah.
Thank you. Thank you all.
All very well put, Paulo and Bob. One thing, just very quickly, I know we're short on time. No matter what it is, you're going to have to look at the failure mode. And depending on the failure mode, you are going to have one instrument that you probably look at first before looking at the other one. So I think understanding the failure mode will also help you in making the decision as to what part of this data volume you're going to want to look at first.
Great. Thank you, Zip. Nani, did you want to chime in? Just got a couple minutes.
Yes, thank you. I just wanted to add on what Bob was saying. It is indeed, this is an emerging issue for all practitioners. For example, we are using autonomous drones to do our visual inspections. So what happens is that every time the drone leaves the box to go and collect photographs and videos, so it will go every hour or so. Addition to what the other sensors are collecting, we find that our servers are struggling to process that data such that we can relay the information as quickly as possible to the operators on site that we have picked up this kind of movement. So it's an emerging issue that I think the practitioners, and with the help of IT and IA, like Bob was saying, we need to start addressing it as soon as possible. Thank you so very much.
Yeah. Thank you, Nani. Okay, looks like we are just about out of time. I'd like to take just one moment to plug our professional development course series. As mentioned, right now, we are currently running our geotechnical radar monitoring course, as well as our slope performance monitoring course. And we're also running the first rendition of our fundamentals of open pit slope design course as well. It's a fantastic course, also based on an LOP guidelines book. And just so you know, in June, we will be releasing our water and mine operations and slope stability and structural geology for geotechnical professionals courses. These are going to be reruns, both fantastic courses. And then coming new in 2025, we'll be releasing our blasting and pit slope performance course. So I think that'll be released in September as well. So keep an eye out for those. Okay, so with that, thank you to our panelists. We really appreciate your time. Great conversation. And thank you all who tuned in. Again, we'll be posting this to both the course websites as well as our YouTube page. So if you want to view them again, you can go there. So great. Thank you all so much. Have a great day or evening wherever you are.
Thank you. Thank you.
Bob,
Thank you.
Bye.
Thank you,
Paulo,
Bob.
Bob.
Bye.
Thank you so much.
Bye. Bye, Zip.
Bye, Zip.
Thank you so
Bye,
very much.
Paulo. Bye, Nani. Bye, James.
Bye-bye.
Bye.
Bye.
And Pierre. Cheers.
All right. Take care, everybody. Bye.